Morning everybody, thanks for joining us for the webinar this morning. I'm Claire Barber from MGIS and it's not Mike Darricott this morning, it's Ben Smith who's going to be doing our webinar for us. So I'm going to hand you over to him now. I'll be keeping an eye on any questions anybody's got, and if anybody's having any difficulty seeing anything, hearing anything, let me know as well. So on using the chat box. So I'll pass you over to Ben now and we'll get started. Sorry for the late start. We were just waiting for a few more people to join.
Hello everyone, as Claire says, my name is Ben Smith. I'm a technical support analyst here at MGIS and I'm going to be taking you through today's presentation on Field Mobile, the age of wear it and share it. Now, when MGIS started, the industry was in a position where if you wanted high accuracy, you were using a receiver that was, a couple of kilos, it was pole mounted and it was quite heavy and bulky to move around. We've now moved on to a situation where we've got really accurate receivers that are much smaller. We've got better software that goes with those receivers and we've got better interoperability between the receivers and various different platforms. So our mission, as it says here, is specialities in enabling accurate spatial data to be captured in the field and using seamless, cost-effective workflows to return on an investment in a single project. To do that, we focus on what someone's workflow is and what they need to get out. So just to define what a workflow is, it's the sequence of industrial or administrative tasks and processes through which a piece of work must go through from initiation to completion. And we aim at making that less painless. So to start with, we look at how you can improve an accuracy in the field, how you can share data and other spatial resources effectively, and the fact that there must be ways that are more cost and time effective for mapping, measuring and inspecting, reporting or analysing and predicting results. Now the first step in this for us is GPS or GNSS data. Now the difference between GPS and GNSS is a bit like the difference between a jacuzzi and a hot tub. Every jacuzzi is a hot tub, but not every hot tub is a jacuzzi. GPS is basically a brand of GNSS. And GNSS stands for Global Position Navigation Satellite Systems, and essentially a series of satellites, called constellation, that enables location to be gathered. Now the main two are GPS, which is Global Positioning Service, which is what everybody knows and uses or thinks they use, and that's provided by the US Department of Defense. Then there's the Russian system, which is GLONASS, which is the other major system for Europe and what we use, Global Navigation Satellite System. And then there's Beidou, which is the Chinese, and Galileo in the EU. Now, Beidou is a fully operational system. We get satellites when we do testing and stuff like that here, but they are much more heavily focused on, obviously, China and Southeast Asia than they are in Europe or the Western Hemisphere. And that's where Galileo comes in. Now, Galileo is the European, the final one, currently be set to be launched at the end of 2019, and that's the British one called Patrick. And this technology, all combined, provides worldwide position and coordinates with the use of them. Now, the accuracy of these systems is where we specialise and what we aim at. So to get that right, it's more important to us to know exactly what you're doing in the field. Now, For most environmental practices, you generally need something about decimeter accuracy, and then for surveying and stuff like that, you're going to need centimeter accuracy. And getting this right at the beginning really does change how much things cost and prevents any extras that you don't need to have paid for, and you only find out afterwards. Now, the accuracy of these receivers is a bit difficult. So each satellite is capable of providing 1 meter accuracy freely, and then down to a centimeter accuracy when it's encoded in encrypted form. But what you'll get when you use your smartphone or a tablet is round about 5 meters accuracy. And the reason for that is the onboard software and stuff like that, and how that works and how that brings in the information for use and what it does with that. The next sort of level is what you get when you pay for a GPS chip in something like a Panasonic Toughbook, and that's about 3 meters. And again, it's just an improvement in the software that allows you to use these satellites to their capability. The next level is a meter. Now, what you're at 1 meter, you're using a correction service. This is, I'll touch on this a bit more later on, but it's broadly defined as the SBAS service. To get below a meter, you need to use better and better correction services. So once you get to about 60 centimeters, you're looking at the highest end receivers without annual subscriptions. Some of these can get a bit more accurate, but you know, there's normally, and in most situations, you will see a cost increase for that. Next is the decimeter level, 10 centimeters. Once again, now you're going 10 centimeters lower, you will definitely need a subscription service, whether that is a real-time correction service or a satellite-based correction service. And as you can just see here, these are broadly defined in 4 separate areas: consumer GPS, prosumer GPS, GNSS, sorry, mapping GNSS, and surveying quality GNSS. The reason surveying and things like that are more accurate is because if you get, you know, if you're building a house and you put one corner 10 centimeters further west than it's supposed to be, all of a sudden that room's not square anymore. It'd be really obvious once you get inside. That also applies to things like flood level planning and other things that are critical down to, you know, you can change the way a river flows if it's 10 centimeters too high in one place. Now, this free correction I was mentioning, which is SBAS coverage, the SBAS is the broad name, and it covers different areas depending on which subscription. So in Europe and small parts of Northern Africa, we're covered by the EGNOS system. Now, it does only have a short coverage, and it does get patchier towards the edges. So if you look towards the eastern bloc and south, so you know, North Libya and stuff like that, you should just be getting coverage, but it won't be great. Again, these maps aren't perfect because depending on weather conditions, sometimes places like Egypt and stuff like that can get coverage. We've even had people in Central Africa see coverage of things like Gagan and stuff like that, but it's rare and can't be relied upon. That's when we cross the line into real-time correction services. So there's 2 types. There's network, which is an internet-based one, or the satellite-based corrections. Now, as you can see, there's different things to be thought about this. So with a network VRS, you're expecting to get down to 1 centimeter accuracy, if not a bit lower. Generally, we say 1 centimeter because that's what you will average out at 95% of the time. Whereas you sometimes will see 0.4 of a meter, sorry, 0.4 of a centimeter with better receivers, but you can't rely on it for that. You can't expect half centimeter accuracy with these things. And the same goes for the next level, which is satellite-based corrections. Sorry. The Atlas system comes in several brackets, but the two that we mostly sell are H30 and H10. H10 is a bit of a misnomer because it gives you 8 centimeters accuracy rather than what you'd expect, and H30 does give you 30. There's also H100 service, and that gives you 1 meter accuracy, but is fairly irrelevant for anything in the Northern Hemisphere. There's different, each of these services does have a cost to it, and you do have to buy your GNSS receiver with this in mind. So the additional antenna or firmware upgrades are required, and these need to be thought out beforehand, because otherwise there'll be a cost to upgrade your kit, and sometimes that might be more than it would have been to get it in the first place. This is why defining your accuracy and understanding what you actually need to get in the field is so important. But the advantage of these things is once it's set up, it's continued use. You don't have to do anything else, and there's no need to set up like a base and rover situation, which is basically the old way of getting these accuracies. There are flexible subscription costs to these things. So the Atlas corrections, which are the satellite-based corrections, come in 3-day packages, weekly packages, monthly packages, quarterly packages, and annual packages. Obviously, the longer you subscribe for, the less you're paying relatively, but if you only need it for 3 days, there's no point paying for a year. The network VRS comes in 2 different subscription settings. There's unlimited, which is 40 hours a month, but that breaks down as 120 hours a quarter. Or there's unlimited, which is basically you could run your receiver from 12 in the morning to 12 in the evening with no interruptions for 365 days using their service, no problems, to no extra cost. So all of this is just one type of sensor. So the GPS and the GNSS and the GLONASS is just one variety of sensor. We've been doing some work with Sensor City and the Energy Innovation Centre in particular to work on other sensors and bringing them into what we do. Now, the Energy Innovation Centre, we're working with Northern Gas Networks to implement a system and improving their workflow. Now, this is looking, we've already passed the first round of funding for this, but the second set of funding is coming in, I think, next quarter. Sensor City is a slightly different angle in that we're working with the LoRaWAN network and several companies from Scotland and various other places. And the LoRaWAN network is a essentially low energy, low file size Wi-Fi network with exceptionally high range. So typically one of the LoRaWAN transmitters can send a few bytes of information an hour, which is what you'd need for a text message or something like that. An hour for about 7 years on one battery life, and it can send it for about 15 kilometers. So for someone who is doing, say, isolated surveys, like forestry surveys, where they need just reports on weather or something like that to know what's going on at specific locations, these would be perfect. Or for someone doing things like pipeline inspections, or if they need to know anything from even electric fence monitoring. These have been implemented on in the States, so they know if there's been an interruption to their fencing and stuff like that. But this also links into other sensors and how we can use those. So the standard data collection system outstanding in the field would be to open up your app, plot the location using your GNSS. This here is Samsung showing the EOS tab. I'll touch more on the arrow receivers in a second. And then the input your site data into whatever app you happen to be using. The tier up show of what you can do in the field is to use an external sensor. Now, the device that's shown here is the Spike by Ike, and what that is a small laser rangefinder which can be mounted on a tablet or a phone, as you can see, and it uses its laser rangefinder to be able to plot and draw on areas onto things like that. So as you can see in the picture, this specific example is working out concrete to infill a hole. So they've got the area of this device, of this hole, worked out exactly. They know exactly how much concrete they need. And this can be used to incorporate depth and stuff like that and work out volumes very quickly, very easily in the field with a few clicks of the button. This can be implemented into various pieces of software as well. So for Apple users, you can go directly from the Spike program into Esri Collector. For Android users, we do believe that's coming in the future, but it's not there yet, basically. Conversely, we have our own software, which we've launched towards the end of last year, and we've been rolling out a lot more this year, especially with our arborist customers. The Spike app, the Spike will input directly into an Android phone, and when we launch our iOS platform, hopefully later on this year, it will input directly into that as well. So you'll be able to take these photographs, label up the areas, and save that information onto the photograph, as well as export that information into fields and stuff like that to go back to the office and be shared. And again, as you can see here, you've got various attributes, as well as the picture being stored, easting and northing, and depth, area, and volume. This one's very simple because it's just 1 meter, but you can go from there and export that data further. And then you submit your data. Now, just to touch back onto the GPS side of things, the current generation of hardware has seen a good up step from what we had even 5 years ago. With the units that we had when MGIS started and rebranded and started going a couple of years ago, were very big, very heavy, and very bulky. They had to be pole mounted for anything below a meter, and they were not convenient to be used in any way. They were also all hardwired, so there was very little in the way of Bluetooth technology being implemented on these devices without paying huge premiums. There were radio frequency modulators and stuff like that, but again, there were prices to be paid on top of that, and you had to use a data collector which covered radio frequencies. The current generation, specifically in this example, the EOS Arrow GNSS receivers are much improved. As I'll show you in a case study a little later on, the Arrow devices are much smaller, they're very easy to carry, and they can be mounted on the person or on a backpack, as well as pole mounted if that's what you require. They're very small, and they're very accurate. And similarly priced models tend to be much quicker at getting fixed and getting down to low accuracy than more expensive models from other brands. That's why we've shifted a lot of our focus onto EOS products, because they are so good. Now, once you've collected your data in the field, the next step is sharing that data and sharing the spatial information that you've collected with people in offices and with your clients. What we've brought to the table really is, in a similar style to what Esri have, we've introduced a web portal. Now, the MGIS Spatial Hub allows for master map background data to be overlaid with the data collected in the field in near real time. So again, you've pressed submit in the field, and then this is sent wirelessly through to the cloud, where anyone in the office with a password can log in and see the attributes that you've collected. This can also be downloaded and implemented in various formats: shapefiles, CSV, MIMIF, and AutoCAD files directly from the web, which can be sent on to clients, or clients can have access to this data. Now, we've implemented this system with a arboretum in southern England. They've collected their trees. They've run constant inspections on these trees, measuring heights and widths and stuff like that. Rather than the full BS 5837, it's a much more streamlined version. But this is constantly updating the database and updating the web map for them. So they can pull this information from a web map, or they can pull this information from into QGIS via our desktop programs without any need for the person coming back into the office. So as soon as someone has submitted the data in the field, they have it live and ready to go. And all this leads to spatial data as a service and what we can do with that. So while you have people in the field collecting data, you may not have people in the office who can make particular use of that data or know how to serve that data or can use GIS programs to manipulate that data and show what they want to show. And all this can be done now through this web portal, through the internet cloud-shaped version, cloud-based versions, to be done as a service. So you can pick which element you want from this diagram here. So whether you just want web, whether you want analytics or reports or databases, and the mobile side of things can be implemented directly and output into these formats. And all of this can be done remotely and it can be done by somebody else. So you can outsource this, save time for yourselves, and have this done as a service with all the analytics reports and database updates done for you, as well as being served to a web map. So you can really see the data coming in real time and know that everything is going right. Now, a quick case study, quick first one of two. Wetland Surveys Ireland. Now, Wetland Surveys Ireland looked over several different receivers, and what they really needed was a GNSS receiver that could plug and play into their kit that they already have. And they came across the Arrow GNSS receivers, and they went with the Arrow 100. Now, the Arrow 100 is a mapping grade GNSS receiver, and will get accuracy of about 60 centimeters. It's a high accuracy for a non-subscription and non-real-time service. Now, what they've found in the field is, rather than the 0.6 meters accuracy, so 60 centimeters that was advertised, they found they've been getting closer to 0.4 meters on average, regularly getting down to 20 centimeters and being able to work at that level. Obviously, this is very useful for things like quadrat surveys and rare plant surveys, which is what they spend most of their time in the field doing. These receivers plugged in directly to their current hardware of iPads and iPhones via Bluetooth, and just brought down the accuracy for them so they could do this. They use Esri Collector in the field, which is a free app that anyone who's got an Esri subscription can log into. So bigger companies tend to have these Esri licenses, these ArcGIS licenses. They can log on and use Esri Collector on any iOS or Android device, as well as Windows tablets and stuff like that, which will all talk to the Arrow receivers due to their universal Bluetooth connectivity. This data can then be shared wirelessly through ArcGIS Online, and their employees in the office can get this data and start working with it before the field agents are even back at the office. Our next case study is Northumbrian Water. Now, they were given the task of 13,500 kilometres of pipeline, which needed mapping, including catch pits and other features you'd expect to find on water and wastewater pipe work. The issue they had was the difficulty to access the points that they need to survey. So these things would be in the back of people's houses, they'd be over walls that hadn't been mapped properly and stuff like that. And they needed to be able to get to the point, accurately map it and get out without being there for ages and without making it really difficult and without it being dangerous. What they found is, again, the arrow receivers being implemented with a backpack-based solution to mount the antenna. And this allowed them to have all of their kit safely stored away in a rucksack while they were able to climb over whatever needed to be climbed over, get to wherever they needed to go, and without things getting in the way. They use the Arrow 200, sorry, the Arrow Gold system. The Arrow Gold is with an RPK service. This brings their accuracy down to regularly a centimetre, if not more accurate, and in real time. This is important for elevation modelling, as it mentions on the slide, because if you were to report a water pipe and say that one end was 10 centimetres high, the other end, just based on the accuracy, was 10 centimetres low, all of a sudden that water isn't flowing under the power of gravity and you have to work out how to pump that water. If you then implement the pump based on this faulty information, you spent a lot of money for something that would do it by itself thanks to gravity. The Esri collector side of things has worked really well for them because they can they can collect the information in the field, send it back, and again, they have people working on the modelling in the office straight away. There's no hang up like there were with all the systems, and there's no delay like there were with all the systems. And that's mostly what I have to say. Just to touch on the last few points, it's like our software is called Geography M. It's, as I said, launched towards the end of last year with full rollout going this year. We've got several users already using this in the field. A large contractor for Scottish Power called LSTC have found that within 12 months of rolling out the system, they were our first customers for it. It's already paid for itself and more. And this is a system that's got 10 tablets in the field, 10 user licenses, and well as people working in the office. And all of this works in real time, syncs back directly. I've mentioned the two Esri case studies that we have for things with Collector and the Arrow series and EOS positioning. And that's it from me now. I'd just like to ask if there's any questions. If you want to type them through in the chat menu, I'll be happy to answer those. Okay, doesn't look like there are any questions. You can always email us, the email's up there, sales@mgist.co.uk. My personal one is ben@mgist.co.uk. If you have any questions regarding anything, please feel free to email me. And this has been recorded, so this will be sent out to everyone who signed up. That's it from me, so thank you very much for attending, and we'll see you at our next webinar. Goodbye.